Um, okay, so today we're going to have a look at the sort of like the intro to inheritance. How does Java do inheritance? How does it do this thing where you can compartmentalize, put into modules, different bits of behavior, different bits of state, and then use them all together? It's quite a common thing in object-oriented languages where you can inherit behavior from different places. And so let's have a look at how this works in Java. Now, in order to facilitate this, we're going to work from an app, just a simple Java app that's got essentially a bunch of different tests that we're going to work through. So it's in the repository MSE Java. So if you haven't yet cloned it, go ahead and clone it. There is, inside this directory, there is a workshop app in particular. So this is the one that I asked everyone to work from today. The first step is to make sure you can just run the tests, but we'll get there in a second. Fairly simple, just make sure you use the right version of Java first of all, and then just run your test task. Now, the way this is going to work is there'll be a bunch of errors that you just have to work through one at a time. And they'll introduce you to different rules or different things about the way that inheritance works, specifically dealing with classes and interfaces. So before we all split up to do this, let me talk a little bit about classes and interfaces. The way that I want to do this is maybe just to diagram this out. So we're very familiar, or at least we have some knowledge about how inheritance works using JavaScript. That part of it works very similarly. So if you think back to JavaScript, there was a keyword that we used called extends. And we could use this to extend behavior from one class. And we would have a relationship between a parent class and a child class, where the child class inherits behavior from the parent. Child class extends parent. All right, so this is a fairly conventional idea where you have inheritance, where you have a child class and a parent class. You can always extend behavior from a parent class. So Java does the same thing. We can still use pretty much exactly the same syntax to extend a parent class. All the use cases remain the same. If you want to construct a set of classes that have like a base class, you can think of it maybe. So what work did we do earlier on in the course? Maybe back to Bob's Bagels, maybe you had an item base class and you wanted to create different versions of items. Maybe they would all extend a base class. I just heard someone at my door, so I might have to go grab that. Hold on 1 second, folks. Okay, where was I? I can't remember what I was talking about. Child class extends parent. Yes. Okay. So same use case that we've been familiar with in JavaScript, and also the same pitfalls. So where possible, we try and stay away from inheritance. The problem with inheritance is that sometimes you are not sure what you get when you extend behavior. You don't know how far the inheritance goes back, how many parents there are. And sometimes one class when you inherit behavior becomes this huge thing with lots of different kinds of behavior that you don't expect. So always be careful with inheritance in the same manner. So that aside, let's have a look at the implementation of it and the difference between inheritance using classes and inheritance using an interface. Where possible, always prefer using an interface over inheriting classes. The third part to this triangle is really a kind of class that Java has called an abstract class. And let's make sure we understand the difference between these. So let's talk about an interface. What is an interface and the difference between a class and an interface? So this is all still trying to think about the different ways we can modularize behavior in our programs. Can we create a separate class and inherit behavior? Can we create an interface? What are the different ways we can sort of pull apart a behavior rather than have everything in one place? All right, these are all different techniques of trying to better encapsulate our program behavior. So an interface is a way to essentially create a list of behavior. And the way that this is useful is we can tell when a class implements interface, what it has to implement. And so it creates not only a list of behavior, it also creates like a guarantee that any class that implements this interface, you know what all the methods it has. And you define essentially the interface and in a class can implement it, and no matter what class it implements it, you know it has to have every single one of these methods. So it creates a guarantee knowing that if, say for example, you have a class called student and you have it in your interface a few methods, and we'll have a look at how we define those methods in interface. But if you think of an interface as a list of methods, then that student class has to implement each one of those methods. You can't just pick and choose, you have to implement all of them. So you can set out a list of behavior and then different classes can implement it. And it's a guarantee that any class that implements it has to implement each and every one of them. So this is a useful way to define an interface first of all, and then implement it using a class. So you can essentially create a layer in between a class and your behavior, and say this is the interface that I want, and then any class needs to implement it. And this is quite a common thing that you'll end up seeing when you work with Java. The use of always defining interface first, and then thinking about what classes can implement it. If you think back to some of our approaches using TDD, thinking about what behavior do you want from user stories and from requirements, when you a common way of doing TDD in Java is to think about after you've done that is then create your interface and then create the class that implements it or the classes that implement it. So interface becomes quite an important stepping stone to thinking about behavior in Java. Now, An interface in Java has a few, everything has rules, but has a few key things. One is the way that we define methods in an interface is what we call using abstract methods. Because different classes will implement them, we don't have any behavior in an interface. All right, no actual logic. We just say the list of methods. What are the methods that need to be implemented? So you'll see methods that have essentially none of the curly brackets that indicate that the block of code to execute. It will just have something like, let's imagine it has a return type string, and a method called say hello. And in an interface, that's all you would need to say that in my interface, this is the only method that has to be implemented, for example. If you had more methods, you would define them like so. Right? Normally, you would define a method with the curly brackets after it and sort of logic to execute. But in an interface, you don't need this. Right? Not only do you not need it, the idea of an interface is it doesn't contain any logic. It's just the list of methods that have to be implemented. All right. So abstract methods are a key part of an interface. You list your methods, and in the same way, you pay attention to this part of it, which is the method signature. All right. So the method signature is all the information you can get from that first line of a method definition. Its return type, the method name, and any argument types. And this is all the information that you need to understand what the method should be doing. So you can, as you might imagine, you'll be able to create methods of the same name if you include different argument types. This practice is called method overloading. Some of you might have already encountered it, and in this workshop that you go through, there will be opportunities to have a look at that as well. Not only can an interface have abstract methods, you can also, as needed, define default methods. So this is where some of the lines start to get a bit blurred between the responsibility of a class and the interface. An interface, you can define default methods. So this would be more commonly what you think of as a method with a body. And these don't need to be defined in the class that implements it. All right, they just come with the interface. This would usually this was introduced as a way to make sure you didn't always have to update every single class if you then changed your interface. You could just add one default method to your interface in legacy systems that many classes already implemented that interface, and so it was usually a nightmare to change an interface, because then you would have to go and add those definitions in every single class. So where possible, try and stay in your own implementation, best practice, try and stay away from default methods, but we have to know them because they are part of interface, and this is part of the exam. But in general, stay away if you can from default methods, but there's usually a use case when you're dealing with the legacy code. It's usually easier. There's a trade-off. Anyway, we're not talking about the trade-off between clean code and technical debt. Okay, so abstract methods, default methods. Default methods, as you might imagine, come with a method body, so you do use your curly brackets as normal. And in addition, you have to specify as a default using the default keyword. So you just add default before the method in the method signature. Default string say hello, for example. The third, abstract methods, default methods, as you can also use static methods. They would belong to the interface rather than any sort of object that implements it. You can also use static methods. What else do I want to say about an interface? We'll have a look at the implementation in a second. Interfaces can also extend other interfaces. So not to make your life even trickier, but an interface can inherit behavior from another interface. So you can do something like this: interface extends, and then essentially a list of interfaces. So you can compartmentalize, you can modularize your interfaces. If one interface gets too big, you can separate them out. Interface can be modularized. That should be fairly straightforward. Interface can extend other interfaces. Clearly, an interface can't implement an interface. So the two keywords here that we're dealing with is class has access to extending another class or implements an interface. Two keywords. So you'll see the notation: a class extends another class and then also implements an interface or a set of interfaces. And as I was saying, an interface can extend another interface, but it can't implement an interface. It doesn't make sense because classes are things that implement things. Right, classes look at the list of behavior and then have to implement. They look at the methods, and each of them have to be implemented with some kind of method body. Right, an interface's job is not to implement. Its job is simply to list out the required methods that have to be implemented. So an interface can extend other interfaces, and this is you have an option of doing not just one. You can extend any number of them, whereas a class can only extend one other class. So when an interface can extend, it can extend many interfaces, but a class can only extend one class. What other rules do we need to talk about? We haven't talked about any access modifiers. That's not really the point of this, but okay, abstract class. What's the difference between an abstract class and a normal class? Well, the main difference between an abstract class and a normal class is these cannot be instantiated. The process of instantiation is just creating an instance of a class, instantiation. So you can't do something like new and then whatever your abstract class is. You're doing this way. This would throw a compilation error. All right, if your abstract class is if your class uses that abstract keyword, you can't create an instance from it. It would not be allowed. So you can inherit behavior of an abstract class, and it will be something in the workshop that will in the exercise that you'll do. You'll see that yourselves. And so you can inherit behavior, and that's what usually abstract classes are for. A base class that you can't actually create an instance of, but you can. Its purpose is to be implemented, to be extended. So we have normal classes, we have abstract classes, and we have interfaces. And these are all different ways that we can separate out behavior and then sort of combine them in different ways. So let's have a look at this application. When you run it yourselves, you can either run it you open up in your editor. Just make sure you open up the workshop app, this one here, at this level. So this should be your working directory, workshop app. Either open up in an IDE as a Gradle Java project, or just run it from your command line and using Gradle to run your test task. There are going to be, let's have a look at both of these. So there are a set of 3 different packages that you will be working with, and you'll be able to explore the different uses in how they work. If we start off in the test directory, when you run your tests, there'll be errors, and you'll have to work through one at a time, reading the error messages and resolving them. So let's have a look at some of them. Let's have a look at this one. Might be easier if I open it up in my editor. So these are there's no complicated logic. It's just new things, and they try to keep everything quite simple. And so in this test, for example, these 3 tests, all you need to do is run this task, and you'll see all the output, and there'll be a bunch of compilation errors. We'll have a look at doing that in a second. But if we walk through it, we can have a look that this test is trying to create an instance of this class, and then calls to methods and asserts on their return values. So this test is named test constructor. So there's going to be something about making sure there's an available constructor function to use. So if we have a look at the adult class, is this the right one? This is currently the adult class. As you can see, it extends another class. So you'll have to go have a look at the definition for this class. There's a variable here, and there's a constructor function. And it looks like you'll need to define more instance methods, or at least one below. So in this example, you might see that this might be able to be run, but you might get some errors on these 2 functions so far. When you you might as well find this out by yourself. But I was going to say, when you extend a class, you must make sure there's a constructor available to be used, because when you set these properties, you need to make sure that these variables, if they're not defined in this class, they're available in the parent class. So name and age would have to be available either an adult or person. And if they're not here, you have to go find them in the person class. So there's going to be a few things you're going to have to just like take your time slowly, just to make sure that your sort of mental picture of the relationship between these classes is good. And then we'll definitely have a Q&A as we go through. So then there's another test here for a void method. So the set name, you have to make sure that you define this method, and the get name should already be there. So this test is all about making sure that you are able to create a void method. And in the same way, there's a static method as well for you to make sure that you add in. So you have to call this method. So the idea behind this one is in your class, you have access to this variable, but it's a static variable. So you have to define a static method to have access to it. Let's have a look at running the tests. Let's just have a look at running the test. Cool. So you'll have to read through. So I would start at the very top and have a look at this first error and read through it. So here, for example, it says in the person test on line 27, the constructor is not, there isn't an available constructor to be used. So let's go have a look at that. Person test line 27. So it tries to run this line. Person is a new person with one argument. Let's go find the parent definition. No, person definition. And as you can see in this class, if you're trying to call that constructor function, there isn't one. And so the way to resolve this test is to define a constructor to be able to be used. So the type that we needed was something like this. To be able to resolve that error message. When you read this, constructor person is not available to be used because found there was a constructor with no arguments, but we needed one which actually had an integer type. So this would be an example of trying to make sure you are understanding the connection between the different constructors, also overloading the constructors, so you can have a number of different ones with different kinds of arguments as we go forward. So once you go through all the compilation errors, then your code can actually compile, and then you might find that there are still some test failures. So then you actually get to the assertions. So the first step is making sure your code can compile properly. And then the second step will be to resolve any remaining test failures. When there's a mismatch between, for example, I don't know, this line, right? So when this actually can compile and get executed, then you make the comparison between these two things. So there's a difference between the compilation errors and then the actual test failures, all right? Let's, what else do I need to mention? When you get down to the abstract class, this method here should always remain commented out. This is here just to show you that if you were to run this test, it would cause a compilation error. So it's just named accordingly, just so you can see that if you try to create an instance of an abstract class, it will not compile. So this will always fail. So keep it commented out, but you can play with it if you want to see it actually run. As you notice, there are a bunch of commented out tests just to try and reduce the noise for you, rather than have like 20 errors. Just focus on these first few, and then once they're passing, you can start to uncomment the other classes, the other tests out. All right. Okay. So this should lead you through working with methods in classes, interfaces, and abstract classes, and then we can discuss questions after you've gone through this. I imagine it might take some time, so let's see how far we get. And as you go, if you have any questions or blocks, just shout out and tech help on Discord. I imagine there'll be probably just making sure you can get started and running the tests, then it should start to get easier. Okay, before I let you all go, my question to everyone is, do you understand what you're going to be doing for the next hour? And what questions do you have if you're unsure? Couple thumbs up. Cool. Okay. If you get stuck, shout out on tech help. Your task is to resolve these test errors. And by doing that, getting more familiar working with these different kinds of inheritance, classes, abstract classes, and interfaces. All right, that's it from me for the moment. Shout out on Discord. Otherwise, we will gather back at 11 just to see where we are all at. All right. All right. See you then.